Welcome to this video. In this session, we are going to discuss about integration methods. The three important techniques to evaluate the integrations are, one is substitution method, and second one is integration by parts method, and the third one is partial fraction method. The first case, the substitution method, is used to simplify the function into a smallest form. The complicated function is changed into a simplest form. We have to make one more variable simplified into another variable, and with the help of the basic integration formula we can evaluate this integration. Basically, this integration is used to calculate the area for definite as well as indefinite integrals. If it is a definite integral, we able to calculate from the limits a to b or any limits. So let us consider the problem. Evaluate integral 3 to 5 2x minus 3 divided by root of x square minus 3x plus 1 into dx. Here we are adopting a substitution method because the denominator part having the a root of x square minus 3x plus 1. This is not easy to integration with the help of the simple formulas. For that we are using a substitution method, the first method. Put x square minus 3x plus t equal 1 equal to t. We have to differentiate on both the sides. It become 2x into dx minus 3 into dx is equal to dt. Then we can take out this dx out, which is equal to dt. Whenever you are changing a variable into another variable, we must check the limits. Say the lower limit we are having 3. When x is equal to 3, we have to check for t. Substitute in this equation. What we have to adopt? T equal to x square minus 3x plus 1. Therefore, t equal to, you substitute x is equal to 3 in this equation, it become 9 minus 3 into 3 plus 1. So this is equal to 9 minus 9 plus 1. Minus 9 plus 9 getting cancels. We get t equal to 1. When x is equal to 5, then we have to check for t. The limit t, the upper limit. The t equal to 5 square become 25 minus 3 into 5 plus 1. So substitute this x is equal to 5 in this equation. Therefore, t equal to 25 minus 15 plus 1, that is equal to 10 plus 1. So t varies from 1 to 11. See, we have to change this integration by introducing a new variable, that is called a substitution method. See, we get 2x minus 3 into dx is equal to dt. For this 2x minus 3 into dx, we can write it as dt. The integral varies from 1 to 11 divided by root t, because we already taken x square minus 3x plus 1 equal to t. You have to integrate this case 1 to 11. This root t can be written as t power 1 by 2. If it goes in the numerator part, it become minus 1 by 2 into dt. So this is equal to integral 1 to integrate with respect to t. So it become, according to the formula, integral x power n into dx equal to x power n plus 1 divided by n plus 1. So it become minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. The limits, it varies from 1 to 11. So this is equal to t power 1 by 2, because minus 1 by 2 plus 1 become plus 1 by 2 divided by 1 by 2. The limits 1 to 11. So which is equal to, so the reciprocal is 1 by 1 divided by 1 by 2 become 2 times of t become 11, applying the upper limit, 11 power 1 by 2 minus 1 power 1 by 2. So or you can write it as 2 times of root 11 minus 1 is the answer for this problem. Evaluate integral 0 to 5 2x minus 3 divided by root of x square minus 3x plus 1 into dx is evaluated over the period 3 to 5. We give the result as 2 times of root 11 minus 1 is the answer for this problem. Let us consider the second problem. Evaluate integral 2x divided by 1 plus x square the whole square into dx. See, the denominator we are having 1 plus x square the whole square. Here also we are going to adopt a substitution method. These methods are depends upon the function, either it is a substitution method or integrating by parts method or partial fraction method. If the function is so tedious, we are using a substitution method to make the simplified form. Here I am putting t equal to 1 plus x square. Differentiate on both the sides. It becomes 2x into dx because differentiation of 1 is 0. There is no limits here, so it is an indefinite integral. So just you are substituting for these values 1 plus x square the whole square and 2x into dx. So this is equal to, see, this 2x into dx can be written as dt divided by 1 plus x square. We have taken 1 plus x square equal to t the whole square because we are having the square form. So this is equal to integral, can we write it as minus 2 into dt. According to this formula, it become t power minus 2 plus 1 become minus 1 divided by t power minus 1 divided by minus 1 plus c. This is an integration constant. So we can write 1 by t plus c, but this is a variable. What we have taken t equal to 1 plus x square. So we have to substitute that t is equal to 1 plus x square. Finally, we get the result as t equal to the integration of indefinite integral 2x divided by 1 plus x square the whole square is equal to minus 1 by 1 plus x square plus c. Suppose if we are having the problem, the function as x into e power x square into dx. See, this function is not easy by using any of these method, either by integration by parts method or Bernoulli's method or partial fraction method. We have to substitute it for x square. See, this integration is used to find out the area of the function in the closed interval. Here this is an indefinite integral, so the result is in terms of a variable. Here I am going to substitute x square equal to t, which implies 2x into dx is equal to dt. Therefore, the given integral x square e power x square into dx can be written as, see, we are having only x into dx combination, but we have 2x into dx is equal to dt. That implies we make it as x into dx is equal to dt by 2. So this is equal to integral x dx equal to dt divided by 2. Then e power our x square, what we have take x square is equal to what? T. So this is equal to t. So 1 by, take the constant out, e power t into dt. We know the integration of e power t is e power t plus c. So this is the answer for this problem, if it is a complicated one. So use the substitution method. Then if the problem is like this, integral of log of 3x divided by x into dx. So this is the integral log of 3x into dx is easy, but integral log of 3x by x into dx is not easy by using basic integration formulas. So we use the substitution method here. Solution: put log 3x is equal to t, which implies differentiation of log x is 1 by 3x with respect to x. So it becomes dx is equal to dt. There is no limits. So we have 1 by x into dx only in the given equation, that is log of 3x divided by x into dx, that is 1 by x into dx can be written as integral of, this implies 1 by x into dx is equal to, this 3 goes this side, 3 into dt, because in the function we are having only 1 by x. So you make it as 1 by x, not 1 by 3x. So you bring this 3 the right side. So it become integral 1 by x dx can be written as 3 into dt. Then this log 3x have taken as t into 3 dt. So this is easy for integration. T t into dt. See how it is simplified. T square divided by 2 plus c. So this is equal to 3 by 2 times of our t is log 3x the whole square plus c is the answer for this problem. Suppose the problem is of the form integral 0 to 1 is a definite integral 5x into root of x square plus 3 into dx. See, 5 into root of x square plus 3 into dx means we have a formula, but integral 0 to 1 5x into root of x square plus 3 into dx is not easy to integrate. So we use a substitution, we adopt a substitution method here. Solution: put x square plus 3 equal to t, which implies 2x into dx is equal to dt. We have the limits also, right? So we have to check the limits. When x is equal to 0, that implies we have to check for t. If you substitute x equal to 0, t equal to 3. When x is equal to 1, which implies t equal to, substitute x is equal to 1, t become 4. 1 square plus 3, that is equal to 4. So therefore the limits varies from, instead of 0 to 1, we have to substitute 3 to 4. Hence the given integral become x square plus 3 into dx. We are evaluating this integration. So this is equal to, this integration is equal to the limits t varies from 3 to 4. 3 to 4. 0 to 1 is replaced by 3 and 4. Right? Then see, we are having only x dx combination. We have x dx combination. So this implies only we want x into dx. We can write it as dt by 2. Instead of x dx, you take out this 5, this is a constant. So x dx can be replaced by dt divided by 2. This root of x square plus 3 is equal to root t. See, it more simplified. 3 to 4 root t into dt. We know root t is equal to t power 1 by 2. Hence the integration is 3 power 1 by 2 plus 1 become 3 power t power 3 by 2 divided by 3 by 2. We have the limits here 3 to 4. So this is equal to 5 by 2 times of, see, I am first applying the upper limits. So it become, or you can write it as into 2 by 3. See, the reciprocal is 2 by 3. See, this 2 getting cancelled. See this form. That is 4 power 3 by 2 minus upper limit 4 power 3 by 2 minus 3 power 3 by 2. So this is equal to 2 getting cancelled. We are having only 5 by 3 times. This 4 can be written as 2 square power 3 by 2. This 2 getting cancelled, right? Numerator and denominator getting cancelled. Minus 3 power 3 by 2. Or you can write it as 5 by 3 times of 2 cube. We are getting only 2 cube, that is 8 minus 3 power 3 by 2 can be written as 3 into 3 power 1 by 2, that is 3 root 3. This is the solution for this problem having a limits. This is a definite integral. Suppose the problem is of the form integral 0 to pi by 4 what dx divided by 1 minus sin x. 1 minus sin x. See the denominator, we are having 1 minus sin x. This is not easy for integration. First, if you substitute t for this 1 minus sin x, say sin x integration is minus cos x. Then our differentiation is, sin x differentiation is cos x. So that is not easy for integration. So we have to rewrite this given function as, why are rewriting this given function? Because if you differentiate this sin x, it becomes cos x. There is no cos x in the denominator part. Cos x into dx. So that is equal to dt. So this is not easy. For that case, we are applying a new technique, that is integral 0 to pi by 4 dx divided by 1 minus sin x, or 1 divided by 1 minus sin x into dx can be written as integral 0 to pi by 4 1 divided by 1 minus sin x into, you multiplied and divide by 1 plus sin x. Because see the denominator, we are having a plus b into a minus b formula. So that is a square minus b square formula. So we are getting 1 square minus sin square formula. So it make it as cos square. Then it is easy for integration into dx. So this is equal to integral 0 to pi by 4 1 divided or 1 plus sin x divided by a plus b into a minus b, a square minus b square formula, that is 1 square minus sin square x into dx. So that is equal to integral 0 to pi by 4 1 plus sin x divided by, say we know cos sin square theta plus cos square theta equal to 1. So here we are having 1 minus sin square, so it become cos square x into dx. See, we are having two terms in the numerator. We split this by the linearity property, 1 by cos square x into dx, the another thing by two integrations, 0 to pi by 4 sin x divided by cos square x into dx. So this is nothing but integral 0 to pi by 4, 1 by cos x is secant x, so cos square x become 1 by cos square x become secant square x into dx, plus we split this cos square x into cos x because this is equal to tan x. This is easy for integration. So this is equal to integral 0 to pi by 4 secant square x into dx plus integral 0 to pi by 4 sin by cos become tan x. Then we get 1 by cos. That 1 by cos is equal to secant x into dx. Since we have a formula integral secant square x into dx is equal to tan x plus c. Then one more formula, integral tan x into secant x into dx is equal to secant x. These and all you studied from the differentiation derivatives, that is differentiation of secant x is secant x into tan x and differentiation of tan x is secant square x, just reciprocal to each other. So we substitute here, so it become secant square x is equal to tan x 0 to pi by 4 the limits plus tan x into secant x can be written as secant x, the limits varies from 0 to pi by 4. So this is equal to tan pi by 4 minus tan 0 plus secant pi by 4 minus secant 0. Tan pi by 4 is, we are having tan pi by 4 is 1 minus tan 0 is 0 plus secant pi by 4, or you can write 1 by cos pi by 4. Pi by 4 is 45 degree, tan pi 45 is 1. Similarly, cos 45 is 1 by root 2. So you make it as 1 by cos, secant equal to 1 by cos pi by 4 minus secant 0 is also can be written as cos 0. So just this is equal to 1 0 here plus 1 divided by the value of cos 45 equal to 1 by root 2 minus 1 divided by cos 0 is equal to 1. Since cos 0 1 cos pi by 4 is equal to 1 by root 2. Then tan pi by 4 is equal to 1. Then tan 0 is equal to 0. So this is equal to this plus 1 and minus 1 getting cancelled. The reciprocal is root 2 is the solution for this problem. The next problem, evaluate integral 3x square minus 7x divided by 3x plus 2 into dx. This is a very peculiar function. See, there is a condition that the degree of the denominator should be greater than the degree of the numerator, always. The previous problems, all the degrees of the denominator is greater, but here, see the degree is 2, here the degree is 1. The denominator degree is 1 and the numerator degree is 2. So, we have to make this improper fraction. This fraction is called an improper fraction. when you say it is an improper fraction, if the degree of the denominator is not greater than the degree of the numerator, so that is an improper fraction. You have to make this improper fraction into a proper fraction first. For that, we are using the formula quotient plus remainder divided by divisor to make the improper into a proper fraction combination. So first you take the function, that improper function, that is 3x square minus 7x divided by 3x plus 2. First you have to divide this numerator, since it is a greater degree, so divide this numerator by the denominator, the lower degree. So it become 3 into 3x become, or x into 3x become 3x square, right? Then plus 2 into x, that become 2x. You multiply here by long division method. 3x into x become 3x square. See the signs positive, you make it as a opposite signs here. So these two getting cancelled, right? Already we have minus. So minus 7x minus 2x become minus 9x. Then we have to make this as also minus 9x. For what value we have to substitute here, put here. For that I am putting here minus 3. 3 into 3 become minus 9x, should be the same sign. Then minus 3 into 2 become 6, minus 6. Change the sign. These two getting cancelled. We get plus 6. See, this is called remainder, this is called a divisor, and this is called a quotient. So our formula, this is quotient plus remainder divided by divisor for improper fraction. Say our quotient is x minus 3 plus the remainder is 6 divided by the divisor is 3x plus 2. Now we see this is the degree 1. Here the degree is x power 0, anything power 0 is 1. So 6 into 1 is 6. So the degree is 0 here, the degree is 1. Then we integrate on both the sides. Integral of the given function 3x square minus 7x divided by 3x plus 2 into dx can be written as integral of x minus 3 into dx, two integrations, plus integral 6 by 3x plus 2 into dx. This is equal to, on integrating, x square by 2 minus 3x plus 6 times of integral 1 by 3x plus 2 into dx. This is equal to x square by 2 minus 3x plus 6 times of, we know integral 1 by x into dx is equal to log x formula. So we substitute here. Log of 3x, x is equal to 3x plus 2. No limits. This is the integrating constants. This is the answer for this problem. See how the improper fraction is changed into proper fraction with the help of quotient plus remainder divided by divisor. Then suppose the problem is of the form, the function evaluate the integral 2x plus 2 divided by root of 1 minus x square into dx. 3x plus 2 divided by root of 1 minus x square. Solution. See, this is not a easy integration, so we make a substitution method here. For put t equal to 1 minus x square. Then differentiate on both the sides. dt is can be written as minus 2x into dx. Minus 2x into dx. But see, we are having 3x plus 2 divided by root of 1 minus x square. The integral 3x plus 2 divided by root of 1 minus x square into dx. This can be written as, there are two terms, you split it into two integrations. Integral 3x divided by root of 1 minus x square into dx plus 2 divided by root of 1 minus x square into dx. So this is equal to, you take this 3 out, x divided by root of 1 minus x square into dx plus 2 integral 1 divided by root of 1 minus x square into dx. Now, you see this x into dx, you replace here. X into dx is equal to dt by minus 2. We want only x into dx, you bring this minus 2, so it becomes dt by minus 2. So this is equal to 3 times of integral x into dx is equal to dt divided by minus 2 root of 1 minus x square is taken as t plus 2 times of. We having a formula integral 1 divided by root of a square minus x square into dx is equal to sine inverse of x by a. So we know the differentiation of sine inverse of x by a equal to 1 divided by root of a square minus x square, the reciprocal combination. Here 2 times of sine inverse of x divided by our a is 1. This is equal to, we have to integrate this first term, minus 3 by 2 t power minus 1 by 2 into dt plus 2 into sine inverse of x. So this is equal to minus 3 by 2, that is an integration. See, this goes up. So integral of t power minus 1 by 2 into dt. So when you integrate, it becomes t power 1 by 2 divided by 1 by 2 plus 2 into sine inverse of x plus c, integration constant. So this reciprocal 1 by 2 become 2, 2 getting cancelled, root t power 1 by 2 is root t plus 2 into sine inverse of x plus 3. So the final answer is minus 3 root t plus 2 into sine inverse of x plus c. So that is equal to 3 times of, our t is 1 minus x square plus 2 into sine inverse of x plus c. This is the solution for this type of problem. The next method is integrating by parts method. The formula for integration by parts is integral u dv equal to uv minus integral v du. See, if the problem is of the form integral f of x or log x into dx. So this method is used for if the problem having a functions f of x and g of x combinations, f of x into g of x combinations only, multiplied with function, one function is multiplied with another function. For these type of functions, we are using integration by parts method and also by Bernoulli's method. So first I am adapting that integration by parts method. Here solution, let us consider u equal to log x, because we don't know the formula integral for log x. By using integration by parts only, we can able to find the formula for integral log x into dx. That implies du equal to, the differentiation of log x is 1 by x into dx. Then integral, see the problem having log x, integral log x dx. So we substituted for u equal to log x, then integral dx is equal to integral dv. This integration differentiation getting cancelled, therefore we get x is equal to v. According to this formula, integral u into dv, see this is u integral dv, this can be written as uv minus integral v du. So the given function log x into dx can be written as, your u is log x, v is x log x, our v is x minus integral vx du equal to 1 by x into dx. This x getting cancelled. So we get x log x minus integral dx. We know the value for integral dx is x plus integral 1 into dx. That 1 is a constant. Therefore integral dx is x plus c. So we remember this formula that log x into dx is the formula is x log x minus x plus c. The next thing is Bernoulli's theorem. Bernoulli's formula. It is also of the combination f of x, g of x into dx. The integration is of the form f of x g of x into dx. Suppose u is a function of x, v is a function of x, two functions with respect to x. The Bernoulli formula is keep this u as it is. Then we have to integrate this v. v1 is integration. Then put alternative plus minus and plus, then minus. This is the combinations of u and v, first term. Second term is also a combinations of u and v. So first you differentiate this u. Then the next thing is we have to integrate this v1. It becomes v2. Then put the alternative symbol, plus symbol. Then u double dash, v3, minus etc. Where u dash, u double dash, these are called differentiation. And v1, v2, etc. these are called integration. When you stop this term, if u differentiation gets 0, we stop this term. For an example, let us consider the problem integral x into cos x into dx. Evaluate the integral x into cos x into dx. By the Bernoulli's formula, because we can apply by integration by parts method also. Again we have to integrate the second term, you have to integrate one time. By using Bernoulli's it is very easy. Let us consider u equal to x and v equal to cos x. Then integration become x into cos x into dx is equal to, the first step you have to keep this u as it is, that is x as it is. Then you have to integrate this v. We know integral of cos x is equal to sin x. Cos x into dx equal to sin x. Then integral of sin x into dx equal to minus cos x. Here integral of cos x is equal to sin x u v1 minus u dash. Differentiation of x is 1. Then integration of sin x is minus cos x. Then the next thing, the differentiation of 1 is 0. You stop this term. See u v1 minus u dash v2. This is integration. First you keep this x as it is. This is an integration. Then second you have to differentiate this x, that is u dash. Then integrate this v1, that is sin x, integration become cos x. You put a bracket for each and every u, v1, u dash, v2, etc. So the answer is x into sin x minus of minus, because into you are having minus into minus, that become plus cos x plus c is the answer for this problem by using Bernoulli's method.